Alright guys, today we're in lesson 97. We're going to identify the corresponding angles and corresponding sides of similar triangles. We've worked with this before, but just getting a little more formal with it, maybe a little bit more complex. We're going to use proportions to find the lengths of unknown sides of similar triangles. We've worked a lot with proportions this year, so that shouldn't be a problem. We'll just have to learn how to set it up. And then we're going to use proportions to measure the height of an object indirectly, and this actually relates to similar figures also, and we'll see how that ties in a little bit later. First of all, let's take a look at these two triangles. You can tell by the congruency marks here that angle A, once I get a pen, angle A is congruent to angle Z. And then you've got the congruency marks here for angle B being congruent to angle Y. Now, knowing those two pieces of information, would you say that angle C and angle X have the same measurement? Well, what we know about triangles is that they always have to equal 180 degrees. So if these two equal this, and you add in a third angle to each one, you're going to need them to total 180 degrees. So yes, they would have the same measurement. So that answer is yes. So are triangle ABC and triangle XYZ similar? Well, yes, they are. To have something be similar, they have to have all angles the same measure. Not necessarily all sides the same measure, but the angles do have to have the same measurements. So they would be similar. Now, I'm going to switch things up here a little bit. Let me get rid of all of that. And let's take a look then at the bottom in red. It says list then the corresponding sides and the corresponding angles, or the corresponding angles, corresponding sides. So they already kind of marked the angles for us. Okay, it said that, I'm going to mark my angles right here. Angle A would correspond to angle Z. They would be the same measurement, as we can see by our congruency symbols. And then angle B is corresponding to angle Y. And then that we said that angle C then would correspond to angle X. Okay, not too tough on the angles. They had those marked for us. Okay. Now let's look at the sides. For the sides, segment AB would correspond to segment ZY, or side ZY, because it's between the two corresponding angles. This one is between the angle with the one congruency mark and the two, and the same thing here. All right. Another set of corresponding sides would be BC and YX. I'll mark those in green. Okay, those are the long sides coming out from our second set of congruent angles down to the ones that we do not know, or we did not know at the beginning if they were congruent. We know that they are now. All right, let me switch once more. And our third set of corresponding sides then would be AC and ZX. Again, the sides aren't congruent, but they are corresponding because they are between congruent angles in a triangle, which made the whole shape, the shapes similar to each other. Now, knowing that, this piece of information then helps us determine sometimes missing sides if triangles or shapes are actually similar to each other. The length of corresponding sides of similar triangles are proportional. So let's try that out. Let's set them up in a proportion and then use our test for proportions. So I know from looking at this that 8 corresponds to 4. Okay, those would correspond. And if it's a proportion, I need an equal sign and find the other ratio. So let's take the hypotenuse here. Let's take the 10 and the 5. Now, our test for proportions, if you remember from last year, is to do cross products. Do the cross products equal each other? Well, 8 times 5 is 40, and 4 times 10 is 40. So yes, they do form a proportion. Now let's just try one more scenario here, just to make sure that wasn't a fluke. And let's try, let's try this side, the 6 and the 3, and we'll go with the hypotenuse again, the 10 and the 5. Okay. Let's try our cross products. 6 times 5 would be 30, and 3 times 10 would be 30. So yes, they are proportional. Now, where that comes into really help us out is if they give us some of the sides measurements, but they leave one out. For example, here we're solving for A, okay? So what they did is they set up a proportion. We know that this angle, or I'm sorry, this side corresponds to that side. So I put 6 over 10 in my proportion down here, okay? Then on the left triangle, we're going to take a look at this side because it corresponds to A over here. So we put 3 over A. We should be able to figure out the measurement of A now using our cross products, knowing that this proportion is true. So 6A equals 10 times 3, and 6A equals 30, which means side A equals 5. Okay, so we know that A equals 5. And honestly, we could find out what this side is also by setting up in a proportion, but they didn't ask us for that, so we're not going to worry about that for right now. What I would like you to do right now then is go into your book on the practice set problems. Right now, work out A through E on page 673. So again, that's page 673, A through E. Solve those practice set problems in your math notebook. So pause the video, do those, and then come back and we'll hit the last couple slides in the last topic here. Alright guys, now you're going to love this part because this is my artistic talent on display. Okay? We've got a tree. I'm going to try to identify what everything is because you might not be able to tell from my drawing. So I've got a tree. I've got a person standing beside the tree. They are on level ground. That's why I kind of drew the green line at the bottom there. Okay? And there's the shadows. The big gray shadow is the tree's shadow, and there's the little person on the ground. Okay? So the story is that Sarah looked up and said, I wonder how tall that tree is. Beth looked down and said, oh, it's about 25 feet tall. Beth did not directly measure the height of the tree, but instead she used her knowledge of proportions, to indirectly estimate. Okay? Now let's see how she did that. I'm going to draw some triangles here to show you how she figured that out. Okay, so I'm going to connect, and these are right triangles because we go from the ground to the height of, I don't know if that's Sarah or Beth, we'll just say it's Sarah, and then out to the edge of her shadow. The same thing with the tree. I'm going to go from the top of the tree, or to the top of the tree, and then along the ground out to the edge of the shadow and form that triangle. Now, if this ground is level, and of course the sun would be, shining on them at the same angle, these are similar triangles. Now, we just talked about how similar triangles, their measurements are proportional, okay? So, in order to solve this, Beth knew how tall Sarah was, and she could guesstimate how far her shadow was out there, and then guesstimate the height of the tree. Now, this isn't necessarily going to come out to be the 25 feet, but I want to plug some numbers in there. So let's say just that Sarah is 5 feet tall. And let's say, we'll just use some easy numbers here, that her shadow stretches out 10 feet. Okay? If we know that she is 5 feet tall, and her shadow is stretching out 10 feet, and we assume that those two right triangles are proportional, she could measure out how far the length of the shadow of the tree is, and then figure out how tall the tree is without climbing up there and measuring it. So I'm going to, let's say that this down here, we'll just say that it's 30 feet. This tree's shadow is 30 feet, okay? So we're going to put this down here at the 30 feet. And I want to know how tall the tree is. Okay, so again, the 5 is the height of Sarah. The T is the height of the tree. The 10 is the length of her shadow. The 30 is the length of the tree's shadow. If we do our cross products, then we have 10T equals 30 times 5. 10T equals 150. And that makes T equal 15 feet. So this is a 15-foot tree. Not super duper tall, but it is a 15-foot tree. Okay, now let's try another one where maybe you won't have to deal with my lack of artistic ability here. To indirectly measure the height of a telephone pole, some students measured the length of the shadow cast by the pole. So I'm going to draw a pole here, okay? And that's the height, and then I'm going to draw this out to be the shadow here. If I can get my, there we go, stylus to work. So the shadow measured 24 feet. They did know that. All right. Then there was a meter stick, and I'm going to put that in red. Okay, so you've got a meter stick. Obviously, it's 1 meter. Okay. And it casts the shadow. Let's see, what's it say? 40 centimeters. Okay, so 40 centimeters out. So short shadow here. Okay. And they want to know about how tall is the telephone pole. So let's make that y. Okay, now I'm going to complete my triangles here. So you can see that these are similar figures. Whoops. Oh, hold on. Let me go back. There we go. All right. There we go. Connected out to the shadow. Okay. Now let's set up a proportion here then. We've got that y would be corresponding to the 1 meter. Okay? And then we know that the 24-foot shadow corresponds to the 40 centimeters. Now, I've got one issue here, and that is that our meters and centimeters are in different units. So what you need to do is, you need to change those in the same units. We know that a meter is 100 centimeters. So let's just go ahead. I didn't write the 40 in there, did I? Let's make that 100 centimeters. Then we can use our cross products. Let me get rid of my triangle here. Kind of running out of room today. All right, so if we go back to our cross products, then we are 40y equals 24 times 100. 40y equals 2400. And so y would equal 60. Now, we got to think about what does that 60 mean? Well, we were trying to figure out how tall the telephone pole was, and they were measuring the telephone pole in feet. So it actually would be 60 feet tall. Okay, so if I do this here. Now let's just look at if that makes sense. Down here with the meter stick, okay, the meter stick was longer than the shadow, and here the telephone pole is longer than its shadow also, which makes sense. All right, guys, now you can go back to your book and go ahead and do letter F and G. You can refer back to the last 2 examples to help you if you need to, and then you'll bring those to class and we'll check them in the morning or the afternoon. Thank you.